Hey, I'm a neurosurgeon, Kazu.
You're staring right at the kitchen table. You're frantic, swiping away mail and magazines, looking for your keys. You give up. 5 minutes later, someone else walks over and picks them up from the exact spot you were just glaring at. This happens when you decide to buy a specific pair of shoes, and suddenly, billboards and bus stops everywhere seem to be advertising that exact brand. We usually brush this off as simple distraction because we assume our eyes function like camera lenses. This internal editing process is a biological necessity. The human brain accounts for only 2% of your total body weight, yet it aggressively consumes 20% of your body's energy. Processing 100% of the raw visual data hitting your retinas every second would cause a catastrophic biological overheat. To save power, the brain uses predictive coding. It guesses what will happen next based on your memories, only checking the outside world to see if those guesses were correct. In your visual cortex, 80% of the data is internal prediction. Only 20% is external. Your eyes just scan for errors to correct this pre-rendered simulation, making our conscious reality a controlled hallucination. In familiar environments, the brain relies almost entirely on its internal map. It projects an expected reality and ignores the visual input that doesn't fit the pattern. This predictive filter explains why people can drive a routine commute, get into an accident, and honestly claim they never saw the other car. Their brain projected a clear road because it predicted a clear road. Clinical evidence shows these predictive loops dictate our physical sensations and emotional stability. Neurosurgeons observe this system governing everything from how we feel our own limbs to how we process pain. Phantom limb pain is a severe error in this software. The brain continues to predict and generate physical pain for a body part that has been removed. Chronic anxiety follows the same mechanical logic. The brain's predictive engine gets stuck in a loop, simulating worst-case scenarios and treating that internal simulation as a current physical threat. These stressors represent mechanical glitches in the brain's predictive software, moments where the internal simulation has lost its connection to the actual environment. Once we recognize that our reality is an editable prediction, we can stop being victims of these glitches. We can manually update the code. You can reset the system via intentional observation. On a routine walk, force your brain to find one brand new detail. Focus on the scent of the air or the texture of a wall to pull in raw data that breaks the autopilot. You can also force a system update by physically changing your surroundings. Rearranging a room or taking an unknown route to work forces the brain to abandon its old predictions. An unfamiliar environment creates prediction errors. These errors compel the brain to stop relying on memory and start processing the world as it actually is. To handle anxiety, use a cognitive override. When the brain begins simulating a disaster, verbally speak objective, concrete facts out loud. Feeding the brain factual audio data, like, "I am standing in my kitchen and I am safe," acts as a system override, recalibrating the faulty danger prediction patterns with real-time evidence. Your reality is a draft written by your brain. Understanding the machine gives you the power to clear out the glitches and intentionally construct a clearer, more stable world.